Okay, we're going to be looking at inverse functions. So first of all, what is an inverse function? An inverse function takes all the x's and the y's and it switches them. Simple as that. So imagine if we had some function as followed. So here's x and f of x. And remember, f of x is the same thing as y. So let's say we have x as 1, 2, 3, 4, and just create some function. Let's say we have 3, 7, 10, and 15. And so remember, the idea of a function is that these are all my inputs, and here are my outputs. Okay, well, the inverse function, and we write it like this, f negative 1 of x. And now that's notation. It doesn't mean 1 over f of x. This does not equal 1 over f of x. People think that a lot because they see this, the negative 1 there, but it's not that. So this is just a notation to say inverse of x. And what is it? Well, we take all the x values and switch them with the y values. So my inverse function instead of taking 1 as an input and getting out 3 as an output, now 3 is my input, and I output 1. And 7 would be an input, and I would output 2. And 10 would be an input, and I would output 3. So we're just switching all the x and y values. Simple as that. Now, that's just a very brief overview of inverse functions. Again. So imagine if we have some function f of x, which is y. They're the same thing. And this equals 3x plus 2. Well, my inverse function, remember my inverse function, which I write as follows, I'm just going to switch my x and y values. So now I have x equals 3y plus 2. Well, we want to, so my inverse function, I'm putting a colon to say it is this. And now let's solve this for y. So if we subtract 2, we have x minus 2 equals 3y, or y equals x minus 2 over 3. And this is an equation for my inverse function. Well, what does that look like graphically? So imagine, if we graph our first equation, and we have, so in our first equation, it has a y-intercept of 2 and a slope of 3. So that would be like here and here. So we've got this line like that. And my next equation has a y-intercept of negative 2/3. And this, it might help to rewrite this as 1/3 x minus 2/3. So it has a y-intercept of minus 2/3, and we're going to do this one in blue. And a slope of 1/3, so something like that. And the idea here is that we're just taking all of the x and y values and switching them. For example, here we had the point 0, 2 on my function, and then on the inverse function, I've got the point 2, 0. And similarly, on my inverse function, here, this was the point, that y-intercept, that was the point, let's see, 0, negative 2/3. And on my function, I've got the point, that point there, which is negative 2/3, 0. So we're just switching the x and y's. And you may have seen this before, but what's really cool about this, since we switched the x and y's, and we'll think more about this later, but what happens is it ends up being, these become reflected mirror images always over the y equals x line. So a function and its inverse are mirror images over the y equals x line. Okay, so that's just a brief little introduction, or review rather, of inverse functions.